Hello everyone, this is Aminur Rahman and welcome to the physics project. We talked about the basics of projectile motion and how to derive the equations in the previous two videos. If you haven't watched those yet, do check out the AS playlist on our channel. You will find those as the first two videos in this series. Today we are going to solve several mathematical problems on projectile motion so that you can approach almost all the mathematical problems there are for AS level physics or engineering admission tests like JEE or BUET. Before we start solving two-dimensional problems, let's clarify the directional issues with a one-dimensional vertical projectile problem. Let's say this is the ground level. An object is thrown upward from A with an initial velocity of u. Height of the point A is h. The object follows a pathway like this. Though I have drawn two parallel red lines, the object actually moves along the same vertical line. Parallel lines are drawn to differentiate the upward and the downward pathways. The object moves upward first and reaches the maximum height at B, and then starts falling downward and reaches the ground at C. In IGCSE, we learned if an object is thrown downward, the equation to use is h equals ut plus half gt squared. And if the object is thrown upward, the equation to use is h equals ut minus half gt squared. Now, none of these equations will work here. To understand the why, we need to consider the directions of the vector quantities involved in this equation. For this problem, displacement h is downward, as its initial position was at A and the final position is at C. Initial velocity u is upward and the acceleration due to gravity is always downward. Now, if we consider the upward direction to be positive, the equation for this problem would be negative h equals ut minus half gt squared. But if we consider the downward direction to be positive, the equation for this problem would be h equals minus ut plus half gt squared. You can use any of these two equations to solve the problem. What we learned here is very important to solve the mathematical problems of projectile motion. We will use this idea again and again throughout this video. Remember that you can take any direction to be positive and the vectors that are in the opposite direction would be negative. Now let's start easy with mathematical problem 1. An object is launched at a velocity of 20 meters per second in a direction making an angle of 25 degrees upward with the horizontal, and it returns to the same level after some time. So the diagram would look something like this. Now part A. What is the maximum height reached by the object? To solve this, you need to remember that the final vertical velocity component becomes 0 at the maximum height. So we need an equation that has both final vertical velocity component and vertical displacement in it. Vy squared equals uy squared plus 2ay into y serves our purpose. Final vertical velocity component is 0 at max height. So Vy equals 0. We know uy is u sine alpha or 20 sine 25 degrees. Ay is negative 9.81, as both initial vertical velocity component and max height are upward. So taking upward direction to be positive is convenient for us. And vertical displacement y is replaced with hmax. Hmax is made the subject and therefore hmax equals 3.64 meters. Now part B. What is the total flight time of the object? To solve this, we are going to use the vertical displacement equation. We know that the vertical displacement after the whole flight is 0 as the object returns to the same height level. So y equals 0. We know the values of uy and ay. Let's make t the subject. So total flight time t equals 1.72 seconds. Now part C. What is the horizontal range of the object? Horizontal range means the total horizontal distance it travels during the whole journey. So range r equals horizontal velocity component into total flight time. Let's input the values. So range equals 31.2 meters. Part D. What is the magnitude of the velocity of the object just before it hits the ground? So they are asking about the velocity here. Let's say its horizontal component is Vx and vertical component is Vy. Using Pythagoras, V equals square root of Vx squared plus Vy squared. Vx equal Ux as horizontal velocity component never changes, and Vy equals Uy plus Ay into t. Let's put all the values. Once again, ay is negative g, so speed equals 99.99 or 20 meters per second. Now mathematical problem 2. A ball is kicked at an angle of 35 degrees with the ground. First question is, what should be the initial velocity of the ball so that it hits the target that is 30 meters away at a height of 1.8 meters? The diagram would look something like this. To solve this, let us use the horizontal displacement equation first to find an expression for time. Now let's use the vertical displacement equation and input t equals 30 over u cos 35 degrees along with other given values. Let's simplify and find the value of u. Therefore, u equals 18.3 meter per second. Now part B. What is the time for the ball to reach the target? To find the time taken, we can use both the horizontal and vertical displacement equations as we have all the required values by now. But we are going to use the horizontal displacement equation as it is simpler. Let us make t subject and put the values. Therefore, t equals 2 seconds. Mathematical problem 3. A ball of 600 grams is kicked at an angle of 35 degrees with the ground with an initial velocity of u. First question is, what is the initial velocity u of the ball if its kinetic energy is 22 joules when its height is maximum? The diagram would look something like this, and the max height is here. We know that the vertical velocity component is 0 at maximum height, but overall velocity is not 0 there because the horizontal velocity component is still there and the ball is moving. So kinetic energy at maximum height equals half into mass into horizontal velocity component squared. We know Vx equals ux at any position during the journey. Let's input the values. Therefore, u equals 10.4 meters per second. Part B. What is the maximum height reached by the ball? Let's try to do this with a slightly different approach. Let's use the law of conservation of energy to find this. When the object was launched, it only had a Ke, but at max height, it has both Ke and GPE. So initial Ke equals Ke at max height plus GPE at max height. Let's input all the values. Therefore, Hmax equals 1.8 meters. Mathematical problem 4. In a castle overlooking a river, a cannon was once employed to fire at enemy ships. One ship was hit by a cannonball at a horizontal distance of 150 meters from the cannon, as shown in the figure below. The height of the cannon above the river was 67 meters and the cannonball was fired horizontally. Part A. Show that the time taken for the cannonball to reach the water surface after being fired from the cannon was 3.7 seconds. Assume air resistance was negligible. Let's take the initial velocity to be u. As the cannonball was launched horizontally, angle with the horizontal is 0 degrees. Therefore, u cos alpha equals u cos 0 degrees equals u. And u sin alpha equals u sin 0 degrees equals 0. We are going to use vertical displacement equation to find the time. But why this one? Why not the horizontal displacement equation? Look at the equation. U sin alpha is 0, so we don't have to deal with that and we can find the time directly from this equation as everything else is known. Also, check the signs of every vector quantity in this equation. Both vertical displacement and acceleration due to gravity are downward, so taking downward direction to be positive was the convenient decision. Now let's input all the values, therefore t equals 3.7 seconds. Now part B. Calculate the velocity at which the cannonball was fired. So we have to find the value of u. Let's use the horizontal displacement equation to find that. We know u cos alpha is u for this problem. Let's make u the subject and put the values. So u equals 40.5 meters per second. Part C. Calculate the vertical component of velocity just before the cannonball hit the ship. So let's use the vertical version of v equals u plus at. Be careful about the signs of the vector quantities. Let's put the values. Therefore, v equals 36.3 meters per second. Part D. Find the magnitude and direction of the velocity of the cannonball just before it hit the ship. So we need to find this velocity v here, where vx and vy are its horizontal and vertical components, and theta is its angle with the horizontal component. Now, Vx equals ux as horizontal velocity component doesn't change, so that equals 40.5 meter per second. We just calculated the final vertical velocity component Vy. We will use Pythagoras to find V. Let's put the values. Therefore, V equals 54.4 meters per second. To find the direction, we will use tan theta equals Vy by Vx. Let's put the values. Therefore, theta equals 41.9 degrees. Mathematical problem 5. A shot is projected upwards from the top of a cliff with a velocity of 28 meters per second at an angle of 30 degrees above the horizontal. It strikes the ground 52.5 meters vertically below the level of point of projection, as shown in the diagram below. Part A. Find the horizontal distance from the point of projection at which the shot strikes the ground. As vertical displacement is given, we will use that to find the time to hit the ground first and then use the time to find the horizontal distance. So we will use vertical displacement equation. Careful about the positives and negatives before the vector quantities. We are taking upward to be positive, as both vertical displacement and acceleration due to gravity are downward. Those two are negative, but initial vertical velocity component u sine alpha is upward, so that one is positive. Let's put the values, rearrange the equation to solve the quadratic. Therefore, t equals 5 seconds. Now let's use the horizontal displacement equation. The values are known, so horizontal distance is 121 meters. Part B. Find the speed of the shot as it strikes the ground. So we need to find the v here. And to find v, we need to find both vx and vy at that position. Horizontal velocity component never changes. So vx equals ux equals u cos alpha. And we know the values. Vy equals u sine alpha minus gt. Careful about the positives and negatives. Initial vertical velocity component is upward, so that's positive. G acts downward, so it's negative. Let's put the values. Therefore, Vy equals negative 35 meters per second. As we took the upward direction to be positive, Vy came out to be negative to show that it works downward. Let's use Pythagoras to find V now. Values are put. Therefore, V equals 42.6 meters per second. Mathematical problem 6. The objective of a game is to throw a ball B from a point A to hit a target T, which is placed at the top of a vertical pole as shown in the diagram below. The point A is 1 meter above horizontal ground and the height of the pole is 2 meters. The pole is at a horizontal distance of 10 meters from A. The ball B is projected from A with a speed of 11 meters per second at an angle of elevation of 30 degrees. The ball hits the pole at C. Part A. Calculate the time taken for B to move from A to C. Let's use the horizontal displacement equation. As the horizontal displacement is known, let's make T the subject and put the values. Therefore, T equals 1.05 seconds. Part B. Show that C is approximately 0.63 meters below T. So we need to find this vertical displacement y first. Let's take the vertical displacement equation. Careful about the positives and negatives. We took upward direction to be positive. Y is upward, so positive. U sine alpha is upward, so positive. And G is downward, so negative. Putting the values, therefore, y equals 0.37 meters. A is already 1 meter above the ground. Vertical displacement y is above the level of A. So distance below T is 2 minus 1 minus 0.37 and that's 0.63 meters. Part C. The ball is thrown again from A. The speed of projection of B is increased to v meter per second. The angle of elevation remaining 30 degrees. This time B hits T. Calculate the value of V. Let's use the horizontal displacement equation first to find an expression for time. Horizontal displacement and angle are still the same. Just the initial launch speed is changed to v. Therefore, t equals 10 over v cos 30 degrees. Now let's use the vertical displacement equation. Remember that this time the ball hits the target T. Therefore, the vertical displacement from A to T is 1 meter. Let's put the other values along with the expression for T. The only unknown in this equation is V. If we solve it, we get V equals 11.7 meters per second. Mathematical problem 7. A ball is thrown from a point A at a target, which is on horizontal ground. The point A is 12 meters above the point O on the ground. The ball is thrown from A with speed 25 meters per second at an angle of 30 degrees below the horizontal. The distance OT is 15 meters. The ball misses the target and hits the ground at the point B, where OTB is a straight line, as shown in the diagram below. Part A. Find the time taken by the ball to travel from A to B. We are going to use the vertical displacement equation to find the time taken, as horizontal displacement is not known. Careful about the positives and negatives. This time, vertical displacement y, initial vertical velocity component u sine alpha, and g all are downward. So we are taking downward direction to be positive. Let's put the values, rearrange the equation to solve the quadratic. Therefore, t equals 0.74 seconds. Part B. Find the distance TB. When the ball moves from A to B, the horizontal displacement is OB. We are gonna find that using the time and subtract OT from it to find the distance TB. So here's the horizontal displacement equation. Let's put the values. So x equals 16.02 meters. So TB equals OB minus OT, and that equals 1.02 meters. Part C. The point X is on the path of the ball vertically above T. Find the speed of the ball at X. So the point X is actually here. Let's take the speed there to be V. Vx and Vy are its horizontal and vertical components. To find these, we need the time to reach the point X first. Let's use the horizontal displacement equation to find that. Horizontal displacement till x is 15 meters, and the other values are known too. Therefore, t equals 0.693 seconds. Now let's find Vx. We know horizontal velocity component doesn't change, so Vx equals u cos alpha, and putting the values gives us 21.65 meters per second. Equation of Vy is this. Careful about the signs. Let's put the values. So Vy equals 19.3 meters per second. Now using Pythagoras will give us the value of V, which is 29 meters per second. Now that's my time for today. Thank you for sticking around. See you in the next video.